Let's say we're writing a program for a game that models a restaurant. If we wanted our program to have one or more chefs, each with the ability to mix ingredients and clean up, we would create a .java file in which we would define our chef class as a template for defining our chefs. We fill this file with everything we want our chef to be able to do, and any properties we want each instance to have. Remember that all instances of chef will have the identical methods and the same properties, but each instance can have its own particular values for those properties. In the beginning of the file, we declare that we want to write a class called chef. Remember that we code capabilities as methods. Let's say we want any chef instance to be able to mix ingredients and clean up when they're done working. We could write two methods that looked like this. In Java, every class needs to have a special method to allow creation of instances of that class. The method that handles this is called a constructor, and should be the first method you write in every class you define. Unlike other methods, this one doesn't have a return type. That, and the fact that the constructor's name is the same as the class's name, is how you know it's a constructor and not another method. This is the method that is called every time you use the new keyword to instantiate, that is, create an instance of, a class. The main purpose of a constructor, as its name implies, is to construct an instance of the class by initializing, that is, giving starting value to, all of our class's instance variables. Instance variables store the properties of a class, and unlike local variables, instance variables can be used in any method throughout our class definition. Let's say we want to give our chef class an instance variable that can store a hat. We want it to be an instance variable because we want to call methods on it in multiple places within our chef class. Since this is a CS15 project, the TAs have written a support CS15 hat class with a few methods. We can declare an instance variable for our CS15 hat at the top of our class definition like this. Instance variables are not initialized when they're declared. We do that in the constructor, like this. Now we've set our hat instance variable to a new instance of the CS15 hat class. The new CS15 hat syntax calls the CS15 hat class's constructor written by the TAs. Since we created an instance of the CS15 hat class within our chef class, we say that the chef contains a CS15 hat. Now that we've initialized our hat variable, we can use it within any method of our chef class. Let's say that in our mix ingredients method, we want our hat to get dirty, and in our clean up method, we want it to get nice and clean. We see in the Java docs that the CS15 hat class has get dirty and get clean methods. And so we can call them on our hat like this. Since we declare the hat as an instance variable, we can use the same variable in both methods and have a guarantee that the same instance of CS15 hat class will be cleaned or dirtied when the methods are called. If you forgot to initialize the hat variable, you would get a null pointer exception. In general, if you run your code and see a null pointer exception, make sure that all of your declared instance variables are initialized in the constructor for that class. Recall that we said our chef contains a CS15 hat because the chef created or newed the CS15 hat instance. Once the chef has created the CS15 hat instance, we say the chef knows the CS15 hat instance and is therefore able to call methods on it. But let's say a third party, like a restaurant class, creates the CS15 hat instance instead, because chefs don't often make their own hats. We still want our chef to know the hat and therefore be able to call methods on it. We say we want our CS15 hat to be associated with our chef. To set up this association, we modify the chef's constructor by declaring a parameter of type CS15 hat in it. In order to complete the association and be able to call methods on the CS15 hat instance throughout our chef class, we store the myHat passed in our instance variable. This line of code tells us that our hat variable now points to whichever instance of CS15 hat was passed in as an argument to the chef constructor. Now, our hat variable is initialized with the specific CS15 hat instance that we pass in, and when we call our mix ingredients or clean up methods, it is that instance of CS15 hat class created by a restaurant instance that will get dirtied or cleaned. Now, when the restaurant creates an instance of our chef class, we will pass in as an argument to the chef constructor an instance of CS15 hat. If you're unfamiliar with this syntax, you might want to revisit Lecture 3, where Andy talks about nesting.